Hi, my name is Eran Segal. I'm a professor at the Weizmann Institute of Science. My background is in computer science and mathematics. I did my undergraduate studies in Tel Aviv University and my graduate studies at Stanford University. And for the past 20 years, I've been running my lab, focused mostly on precision medicine by collecting data from large-scale population cohorts, focusing on multi-omics, clinical and physiological measurements, and trying to identify with that novel biomarkers for diagnostics and therapeutics of diseases. We have shown that artificial sweeteners, which our genes cannot process, actually reach through the gastrointestinal tract and meet eventually the trillions of different bacteria that we have in our body. And these bacteria, by having 100 times more diversity of genes compared to the genes that we ourselves have, can actually metabolize and break down these artificial sweeteners in a way that also changes that microbiome composition, mostly for the worst part, such that we've shown that individuals who consume artificial sweeteners, even for the first time, that can alter their gut bacteria in a way that when transplanted into mice, can cause the mice to develop symptoms of diabetes. And so we believe that certain artificial sweeteners actually can be involved in causing the development of chronic diseases. We have shown previously that our gut bacteria also follow a circadian rhythm clock, much like we have our internal biological clock. These bacteria actually, some of them change diurnally. And when these diurnal patterns actually are disrupted, like when we travel and are jet lagged, then these disruptions can alter the set of gut bacteria such that when transplanted into mice can cause mice to develop symptoms of diabetes, of obesity, and basically of cardiometabolic diseases. So when we do intermittent fasting, we actually are also affecting the food that eventually reaches our bacteria. And for some individuals, this is actually shown to be beneficial. And part of it is through the effect that this has on our gut bacteria. So we know that our bacteria actually follow diurnal patterns, meaning that some bacteria rise and increase and decrease in levels during the day. And these increases and decreases are in part related to just our internal biological clock, but then in part to our feeding patterns. And so when we perform intermittent fasting and don't eat, for example, for 8 or 12 or 16 hours, different people do it at different times, we actually are also having an impact on the diurnal changes that are normally seen in our gut bacteria. Now, in some of these cases, this actually might help to synchronize the bacteria in a way that would be beneficial. And this is still an open area of research of the mechanisms by which intermittent fasting actually improves our health, which we know is the case for many people. And we believe that some of the mechanism underlying that is actually by the way that it affects the intraday changes in patterns of gut bacteria. Yeah, so obviously the integrity and diversity of our gut bacteria is very important. And we know that what we eat eventually gets broken down in part by our own genes and gets consumed by our body. But then in part, it just goes through the gastrointestinal tract and then meets the trillions of gut bacteria that we have and then gets digested and metabolized by them. So what we eat is actually the most dominant factor that affects the health and diversity and integrity of our gut bacteria. So when we eat, we have to think about it as though, because this is the case, we're also feeding our gut bacteria. So when we eat products that contain, for example, artificial sweeteners, we've shown in the past this actually reduces the diversity of the gut bacteria. It alters them to grow bugs that can produce toxic molecules that can cause chronic disease. On the other hand, when we eat a lot of plant-based foods and vegetables and fibers, These are contain elements that our genes cannot break them down, and then they reach the set of the collection of gut bacteria that we have, and they enrich them and they grow particular populations. So we have to eat, I would say, also foods that feed our bacteria, a lot of fibers that's known to increase that diversity. But having said all that, it is also well known that we each have a different set of gut bacteria, and therefore the food that we each need to eat to feed our individual bacteria will also vary from person to person. So I would say there are many lifestyle factors that affect our gut bacteria. The most dominant one, obviously, is the nutrition that we eat, because that provides the direct food to our gut bacteria. But beyond that, other lifestyle factors like our levels of stress, which change many elements in our physiology and eventually affect our bacteria. The amount of time we sleep, the quality of our sleep, all of those also have a big effect on our gut bacteria. That there's been many links and associations shown in the literature, and we know that also because our bacteria also have these diurnal patterns that change and increase and decrease levels of some bacteria during the day and during the night, and we have to be in synchronous with these changes, and so improving our quality of sleep, reducing our levels of stress, increasing the diversity of our foods, eating more plant-based diets, and so on. These will all contribute to a healthier gut, and therefore to a healthier well-being. We have done, and others have done, a lot of work in the field to characterize biological aging versus chronological aging. And biological aging, we've shown, actually is it's very basically linked to the age of each different body system. We can break these down, these biological ages, into different body systems. And when we track these biological ages, we see that people with a higher biological age compared to of a certain body system, as compared to people that are in the same chronological age to them, those individuals are at higher risk of developing disease, typically a disease related to the body system on which the biological age was measured. So for example, we've measured a biological clock for insulin levels, and we've shown that higher levels of insulin then should be the normal for that for the age group of an individual. These actually put people at very high risk for developing cardiometabolic disease, mostly that diseases like prediabetes and diabetes that we know are prevalent in prediabetes 30 or 40% of the westernized world, diabetes in about 10%. So that's one example of a biomarker that is very key to our health. We've also studied the microbiome. The microbiome is really involved in every aspect of our health and disease. The microbiome also changes with age. When it changes with age, we know that the set of molecules that it produces that eventually reach the bloodstream also changes. So that has a major impact, and possibly on multiple different systems of the body. So there are many different bacteria that we see have a pattern that increases or decreases with age, and some individuals who fall off that typical pattern are at higher risk for developing disease. One example, which is even actionable, that people can follow up on, is bifidobacterium. So we know that certain species of that family tend to go down with age, and this decrease, if it decreases too much, it also can cause health issues. Probiotics are still very limited today, but bifidobacterium is actually one of those bacteria that you can get from probiotics. So that is an example of a probiotic that, if somebody has a enhanced decrease in that particular bacteria as compared to people of the same chronological age, that is a condition that can be addressed. And we actually are performing now clinical trials to try and test whether probiotics to people who have deficiency in bifidobacterium can actually improve their well-being, their biological age, at least as far as the microbiome clock is concerned.